Let's break down three major discoveries that paved the way for quantum theory. These are the breakthroughs by Max Planck, Albert Einstein, and Niels Bohr. Each one helped solve mysteries that classical physics just couldn't explain, and together, they laid the foundation for modern quantum mechanics. 1. Planck's blackbody radiation. First up, Max Planck. In the early 1900s, scientists were puzzled by blackbody radiation, basically, how objects emit light when they're heated. Classical physics predicted some crazy, infinite energy at high frequencies, which clearly wasn't happening. Planck's genius idea? He proposed that energy isn't continuous ideas released in small packets called quanta. He figured out that the energy of these packets is proportional to the frequency of the radiation, expressed by the formula EHF, where H is Planck's constant and F is the frequency. This was a huge deal because it introduced the idea that energy comes in discrete chunks, not smooth flows, and it kick-started quantum theory. 2. Einstein's photoelectric effect. Next up, Albert Einstein. In 1905, Einstein took Planck's idea further with the photoelectric effect. He showed that light isn't just a wave, it's also made of particles called photons. Here's what he found: when light hits a metal, electrons are only ejected if the light has a certain frequency, no matter how bright it is. This proved that the energy of light depends on its frequency, not its intensity. Basically, Einstein showed that light has both wave-like and particle-like properties. This discovery was so important that it won him the Nobel Prize. 3. Bohr's atomic model and line spectra. Finally, we've got Niels Bohr. He was trying to explain the line spectra of hydrogen, the specific colors of light emitted by atoms. Classical physics couldn't explain why only certain frequencies of light were being emitted. Bohr proposed that electrons orbit the nucleus in specific, quantized orbits. Electrons don't just move smoothly between orbits, they jump from one to another, and when they do, they absorb or emit energy as light. This explained why atoms emit light at certain frequencies and helped establish that energy inside atoms is also quantized. Conclusion: laying the foundation for quantum mechanics. So, what do these three discoveries have in common? They all show that energy is quantized. Whether it's light, atomic spectra, or blackbody radiation, energy doesn't flow continuously. It comes in discrete packets, or quanta. These breakthroughs help bridge the gap between classical physics and quantum mechanics, setting the stage for all the incredible discoveries that followed. Without these key insights from Planck, Einstein, and Bohr, quantum mechanics as we know it wouldn't exist today.